Ladies and gentlemen, fasten your seatbelts.
Hi, I'm Dylan Miller.
I'm Josh Fick.
And this is Dr. Vonk's electronics class, and this lab is about lab equipment.
Just familiarize yourself with the lab equipment, especially this puppy here. This is a Tektronix 2212 60 megahertz digital storage oscilloscope, which is fancy for...
Wow.
Wow.
Which is fancy for, what is it fancy for?
It's like a little TV screen. Lots of buttons that draws really cool pictures.
Yes, it actually takes pictures of the waveform generated by, in our case, the function generator. Alright, here on the screen we have a 60 hertz sine wave generated by our function generator.
Here we have our vertical controls. This is simply just a positioning tool so we can look at more specific parts of the sine wave here. And then we do have, it's essentially in layman's terms a zoom feature.
Over here, this button we have the position adjustment for the horizontal axis right here. Here we can shift it both right and left, and we can also scale that accordingly. You can see right here our time value is scaling.
We can also scale in our other axis too, from something like 5 volts to 2, and even all the way into 1, 0.5, and 0.2 for a much closer view of the sine wave.
So that was a 60 hertz signal. Now let's use our scaling. Now let's use our scaling knobs to scale in a 6 kilohertz signal. Here's the 6 kilohertz signal. You can see that it's not perfectly fitting in the window, and it just kind of looks like just a bunch of nothing.
So if we adjust our scaling on the horizontal position, we can zoom in a little bit, and we can already see that it's starting to break up into its individual waves. And here at a scale of 5 volts and 0.1 milliseconds, we can see that we now have a very easy to see sine wave.
And if it was of a different voltage, let's say 10 volts, right now it's at 5, you'd just be zoomed in on it too far, so you would have to zoom out. Well, we can't zoom out past 5.
You can't zoom out past 5. So it's essentially if you're zoomed in too far like this, where you have very faint lines, you can't really tell what you're looking at 50 millivolts, you can zoom out, and then you can see as the peaks start to become, you can start to see the peaks on the screen, they become closer together as you change your voltage. Now let's say we wanted to measure the actual frequency of this sine wave.
Another interesting feature on this oscilloscope is the cursor option. See, we've got these two values right there. We got these two lines right there, and we're going to want to line one of them up with the peak on one of the waves
right there.
Now we can take that, we can scale that in and go to another peak, and up in the upper left-hand corner it'll show us the frequency. The
frequency of this one is approximately 5.659 kilohertz.
Cool. Another fundamental feature of the oscilloscope is the triggering function. This is when the oscilloscope will start to take the picture. The triggering controls are located over here, and if we move this over some, we've got it set in manual mode. Right now it's set to trigger every time it reaches a 3.2 volts on the going up slope. So if I move that up, you can see that it's triggering at 3.2, triggering at 0, triggering at negative, and we can also do it going down on the slope too. So here we can see that it's, when it hits negative 2.9, and when it hits, negative 0.4, and if it's out of range, it just won't show anything. But if we run it into the automatic mode, it'll bring us back and show us where it should be.
And then you'll be able to twist the knob all you want, and you won't actually be able to lose your function. It'll just stop at its different peaks. Another fun feature that the oscilloscope can do is it can capture transient signal that, if Dylan claps the two nodes together and it's on auto, it will capture it. But we want to sweep for a quick one, so if we throw on sweep and he taps them together, you can see it quickly flash across the screen. Now that's too quick for us to actually be able to see and analyze. So what we need to do is we put this on signal sweep and we turn on our storage. And we hit reset and the radio light shows on. So when he taps them together, they're within our trigger, which is a positive 2.7 volts. Now we get a picture on our screen of that actual transient signal.
Another interesting feature of our voltage or function generator is that we can run it on VCO mode. VCO mode stands for voltage controlled oscillator. So as our voltage increases on the power supply going into the generator, so will the frequency of the generated function. Here's close to 0 volts, and here's getting up close to 5 volts. You can see the voltage going into the function generator right there as a DC voltage, and the output as being the oscillating sine wave.
Another fun function of the oscilloscope is actually the alternate magnification mode, which, if activated, it displays a times 10, so times 10 magnification of the function we're looking at. So as you increase the voltage, thus the frequency, you can see it continuously does a times 10, which we can also switch to a times 50, and all the way down to, back down to a times 10.
And if you ever, oh, this is fine.
It's still going.
And if we ever have anything out of range on our window, we can hit the beam find and it will zoom out and show, whoa, that could have been out of range. Another button we'll notice is this DC AC button right here. Right now we have it set on DC mode, so if we are to offset our function using the function generator, we'll see that it will go down and up. Now when it's just on AC mode, it automatically centers it with the axis right there, and I'm trying to turn it up and down right now and it's not doing anything.
Another interesting feature with our trigger and our storage is we can actually change the pre-trigger, which can show 25 or 75% of what happens before the actual event is triggered. So if we change it to 75%, and then my partner here triggers, we can now see 75% of the time that happened before the trigger, 25% after it. We can change that and set it again, and it shifts over to show 25% of pre-trigger and 75% after the trigger occurred.
So right now we're on VCO mode right now, but we've got the voltage going into the function generator appearing right there as the DC line. We've also got it plugged into the Z input, which will show intensity. So when we increase our voltage, the frequency goes up, but it also gets dimmer, and the other way too.
Alright, and lastly, and probably one of the most important features of this oscilloscope is that fact that it has an on and off switch. See, it's on, now it's off.